this video we are going to discuss about simple problems in beams. It's a small problem. A simply supported beam AB of span 5 meter is loaded as shown in the figure. Find the reactions at A and B, right? So now we are going to calculate the reaction forces A and the reaction forces B, A and B. This beam is subjected to 3 forces, 3 kilonewton, 4 kilonewton, 5 kilonewton, and the supports are just a simply supported beam, right? At point A and at point B, both are a simply supported beam, right? So now we are going to calculate RA and RB. They are asking RA and RB, right? The distance of A and B, which is equal to 5 meter, which means that the length of the beam, which is 5 meter. Now we are going to calculate reaction forces RA and RB, which means the reaction forces at point A and point B, which is a simply supported beam, right? So now we are going to calculate sum of vertical forces, which is equal to 0, right? So how many vertical forces are there? Reaction force RA and reaction force RB, right? Two vertical forces towards upward, right? So that is in one side, RA plus RB, right? Both are acting opposite, I mean upward direction, which is equal to how many forces are acting downward? 3 kilonewton, 4 kilonewton and 5 kilonewton. Add these. So 3 plus 4, which is equal to 7, 7 plus 5, which is equal to 12. So 12 kilonewton, right? So this is, so RA and RB is acting upward, that's why I am taking positive, and this is negative. So RA plus RB minus 12, which is equal to 0. So rearrange this equation, then finally we got this equation RA plus RB, which is equal to 12 kilonewton. This is equation 1. Now take moment. Now take moment about any point. Say for example, now I am going to take moment about point A, right? So this is the point. Now 3 kilonewton, 4 kilonewton and 5 kilonewton are acting the clockwise direction with respect to this point A, and RA, the reaction force is acting upward, which means anti-clockwise direction, right? So this is downward, it seems like a clockwise direction, and this RB is acting upward with respect to this point, so it seems anti-clockwise direction. So clockwise, which is equal to anti-clockwise, right? So now clockwise, which is equal to anti-clockwise. What is the formula for moment? Force into perpendicular distance. So 3 kilonewton force and the perpendicular distance between A and 3 kilonewton, or between the point where we want to take moment, right? So which is equal to 2 meter, and for 4 kilonewton 2 plus 1, which is equal to 3 meter, and for 5 kilonewton 2 plus 3 plus 2, 4, right? So here take moment about A. So 3 kilonewton into 2 plus 4 kilonewton into 3 plus 5 kilonewton into, sorry, this is 1, right? 1 which is equal to, this is clockwise direction. What about anti-clockwise? RB, right? So RB into, what is the total distance? 5 meter, right? 5. So 3 into 6, 3 2s are 6 plus 4 3s are 12 plus 5, which is equal to 5 RB, right? So 18 plus 5, 18 plus 5, 23, which is equal to 5 into RB, right? So RB, which is equal to 23 divided by 5, which is equal to how much? 23 divided by 5, 23 divided by 5, which is equal to 4.6. So 4.6 kilo Newton. Now we know that RA plus RB, which is equal to 12, RA plus RB, which is equal to 12 kilonewton. We know that. Now we are going to substitute 4.6 value in RB. So RA, which is equal to 12 minus 4.6. So which is equal to how much? 7.4. 7.4 kilo Newton. This is equal to RA, right? So RA, which is equal to 7.4 kilonewton, and RB which is equal to 4.6 kilonewton, right. So this is the answer. Next, it's a simple problem. A simply supported beam AB of span 6 meter is loaded as shown in the figure. Determine the reactions RA and RB of the beam. The beam is subjected to point load and uniformly distributed load. The load is distributed uniformly along the length 1.5 meter. The load which is equal to 2 kilonewton per meter, and one more point load is there, right. So the beam is supported by a simply supported beam, right, simply support. So now we are going to calculate RA, RB, right. So now point load is there. Now we don't know here. See, for this problem, point load is a combination of point load and uniformly distributed load, right. So if uniformly distributed load is there, then we have to convert that UDL into point load, right. So now we are going to convert that point load. So 2 kilonewton per meter is distributed along the length 1.5. We know the formula W into L for uniformly distributed load. W which is equal to 2 into L which is equal to 1.5. So 2 into 1.5 which is equal to 3 kilonewton. 2 into 1.5 which is equal to 3 kilonewton. 3 kilonewton. The load, uniformly distributed load, is converted into point load which is 3 kilonewton, and this point load is acting at a point from the point C, right. So that we need to calculate. So for uniformly distributed load there is no issue, L divided by 2, right. So L divided by, what is the value of L, which is equal to 1.5. So 1.5 divided by 2, right. 1.5 divided by 2 which is equal to 0.75 meter from C. So now draw a diagram, and this is point A, and reaction force RA is acting upward, and this is point B, and reaction force RB is acting upward, and at point C the 4 kilonewton point load is acting, right. So this is point C. The distance between A and C which is equal to 1.5 meter. From C take 0.75. So take 0.75, and this is 0.75 meter, and this is the point C, F for example. So this is the point load which is equal to 3 kilonewton, right. And moreover, from B one more point load is there, 1.5. So from B take 1.5, right. So the distance 1.5, and this is the point called D. At D one more point load which is 1.5 kilonewton. Now this uniformly distributed load is converted into point load, right. Now form the equation, upward force which is equal to downward force, or summation of vertical forces which is equal to 0. So upward force which is equal to RA plus RB, two upward forces which is equal to downward forces, 4 kilonewton plus 3 kilonewton plus 1.5 kilonewton. So RA plus RB which is equal to, what is the value, 4 plus 3 plus 1.5, 8.5 kilonewton, 8.5 kilonewton. So this is one equation we got, right. So this is equation 1. Now we are going to take moment, right. Take moment about point A, right. So clockwise moment which is equal to anti-clockwise, right. So moment which is equal to force into distance. So 4 kilonewton into 1.5. So 4 into 1.5. So this is clockwise, and 3 kilonewton into plus 3 kilonewton into 1.5 plus 0.75, right. 1.5 plus 0.75 which is equal to 2.25. So 2.25 plus one more 1.5 kilonewton is there. So 1.5 into, what is the distance? So which is equal to total distance, how much? Total distance 1, 2, 3, 4. So 4 into 1.5. So which is equal to 6 meter, right. So total distance which is equal to 6 meter. Now we want to calculate the distance between F and D. right, or A and D, the distance between A and D. So 6 meter minus 1.5, right? So minus 1.5, which is equal to 4.5 from this A to D, 4.5 meter. So 1.5 into 4.5, which is equal to RB into 6 meter, right? So 4 into 1.5, 4 into 1.5, which is equal to, for this case, 6 plus 3 into 2.25, 3 into 2.25, which is equal to 6.75, 6.75 plus 1.5 into 4.5, which is equal to 6.75, which is equal to 6 RB, right? So now add these, all those things, 6 plus 6.75 plus 6.75, right? So 19.5, which is equal to 6 RB. So RB, which is equal to 19.5 divided by 6, which is equal to 3.25 kilo Newton. So this is the value of RB. Now we know RA plus RB, which is equal to 8.5. Then RA, substitute RB value in this equation, then minus 8.5, which is equal to 5.25, sorry, 5.25, right? So RB value, which is equal to 3.25, we got. Then substitute this RB value in this equation, then RA, which is equal to 8.5 minus 3.25. So 8.5 minus 3.25, we got 5.25, right? This is the value, right? Now another simple problem. A simply supported beam of span 9 meter carries a uniformly varying load from 0 at end A and 900 mm Newton meter at end B. Calculate the reactions at two ends. So the beam is supported by simply supports RA and RB, right? We want to calculate RA and RB. Now this is the uniformly varying load. We have to convert this uniformly varying load into simply supported, concentrated load, right? So at end A, RA reaction force, at end B, RB reaction force, right? Now we have to calculate this. For uniformly varying load, what is the formula? Of BH, right? So of into B, which is equal to 9 into 900, right? So what is the answer? Which is equal to 9 into 900 divided by 2, which is equal to the concentrated load which is equal to, load which is equal to 4050 Newton, right? 4050 Newton. Clear? Now this uniformly distributed load is converted into point load, and now we are going to find out at which point this 4050 is acting. From A, right, 2 by 3 of L, right? So 2 by 3 of L, which is equal to 9, so which is equal to 6 meter, right? So from A, 6 meter, the point which is called C, at C the point load is acting 4050 Newton, right? Now we have to calculate RA/RB, right? So for that, sum of vertical forces, which is equal to 0, right? So RA plus RB, which is equal to 4050, right? So this is the equation. Now we are going to calculate. Now we are going to take moment, right? Moment about point A, right? So RB into total distance 9, this is anti-clockwise direction, which is equal to 4050 into 6, right? So 4050 into 6, which is equal to 24300 divided by 9, which is equal to RB, right? So divided by 9, which is equal to 2700 Newton. This is RB value. RB, which is equal to 2700 Newton, right? Now we know the equation RA plus RB, which is equal to 4050. Substitute this RB value in this equation, right? So RA which is equal to 4050 minus RB. So now RA which is equal to 4050 minus 2700, which is equal to 1350 Newton, right? So this is the value, right? So converted to point load, which is equal to 4050, and RA plus RB which is equal to 4050, and RB which is equal to 2700, and RA which is equal to 1350, right? This is how we have to solve the problem. Okay, in our next video we will discuss some other different problems. Okay, thank you.